So now let's start by solving question number 1. This says let A is equal to Aij, where this matrix is 2 by 2, where Aij is equal to I plus j, and matrix B to be equal to Bij, a 2 by 2 matrix where Bij is equal to I minus j, and compute ABBA transpose and AB transpose. So question number 1 says A is equal to Aij, a 2 by 2 matrix where this Aij is equal to I plus j, and matrix B is equal to Bij, and it is 2 by 2 matrix where this Bij is equal to I minus j. So now we are to provide the matrix from this statement Aij 2 by 2, and this Aij is I plus j. So let A to be the matrix, this 2 by 2 matrix A11, A12, A21, A22, a 2 by 2 matrix where Aij is I plus j, and this is I and this is j. So now A will be equal to 1 plus 1, that is the I and j. Then 1 plus 2, 2 plus 1, 2 plus 2. So now A matrix will be 1 plus 1, 2. 1 plus 2, 3. 2 plus 1, 3. And 2 plus 2, 4. So this is the matrix from this statement. So now let's produce the matrix B. It's 2 by 2 matrix B11, B12, B21, then B22. And these I and j are I minus j from Bij. So now matrix B will be 1 minus 1 as I and j, 1 minus 2, 2 minus 1, then 2 minus 2. So now matrix B will be 1 minus 1, 0, 1 minus 2, minus 1, 2 minus 1, 1, 2 minus 2, 0. This is matrix B from the statement given. So now we are going to compute these questions. Number 1 is AB. Number 2 is BA. Then number 3 is BA transpose. Then number 4 is AB all transpose. So now let's compute this from the following matrix. Number 1, solution. AB will be equal to a matrix of A is this, matrix of B is this. Then we are going to put them down and multiply them together, and 4. Then matrix B, 0, minus 1, 1 and 0. So now we are to multiply these two matrices. AB will be equal to 2 times 0, which gives 0, plus 3 times 1, 3. Then 2 times minus 1, minus 2, plus 3 times 0, 0. Then 3 times 0, 0, plus 4 times 1, 4. Then 3 times minus 1, minus 3, plus 4 times 0, 0. Now AB will be equal to 3, 0 plus 3, 3, minus 2 plus 0, minus 2, 0 plus 4, 4, and minus 3 plus 0, minus 3. So this is AB. Then now we are going to compute BE. So let's move here. BE. So let's find the matrix B is 0, minus 1, 1, and 0. 0, minus 1, 1, 0. And matrix B as produced is 2, 3, 3, and 4. We have 2, 3, 3, and 4 as matrix A. So now we are going to multiply these two matrices to give the BA. Then 0 times 2, 0, plus minus 1 times 3, minus 3. Then 0 times 3, 0, plus minus 1 times 4, minus 4. Then 1 times 2, 2, plus 0 times 3, 0. 1 times 3, 3, plus 0 times 4, 0. So now matrix BA will be equal to 0 plus minus 3, minus 3, 0 plus minus 4, minus 4, 2 plus 0, 2, 3 plus 0, 3. So this is matrix BA. Then question number 3, it says compute BA transpose. BA transpose. First, what we have to do here, first find A transpose. So here we go. Matrix A is given as 2, 3, 3, and 4. So now we are to transpose this matrix. A transpose will be these rows to column 2 and 3. This row to column 3 and 4. So this is A transpose. Now BA transpose will be the matrix of B times the matrix of A transpose. B is given as 0, minus 1, 1, and 0. Then A transpose is this 2, 3, 3, and 4. Then we are to multiply these two matrices. This implies that BA transpose will be 0 times 2, 0, plus minus 1 times 3, minus 3. Then 0 times 3, 0, plus minus 1 times 4, minus 4. Then 1 times 2, 2, plus 0 times 3, 0. 1 times 3, 3, plus 0 times 4, 0. So now matrix BA transpose will be equal to 0 plus minus 3, minus 3. 0 plus minus 4, minus 4. 2 plus 0, 2. 3 plus 0, 3. So this is matrix BA transpose. So now the last question says we are to compute AB all transpose. AB all transpose. So now first we have to find matrix AB. That means matrix A multiplied by matrix B. Matrix A is given as 2, minus 2, 2, 3, 3, and 4. Then matrix B is given as 0, minus 1, 1, and 0. So now we are going to multiply this matrix all transpose. So now these will be AB all transpose will be 2 times 0 plus 3 times 1, 3. Then 2 times minus 1 minus 2 plus 3 times 0, 0. Then 3 times 0, 0 plus 4 times 1, 4. 3 times minus 1 minus 3 plus 4 times 0, 0. Then now AB all transpose will be equal to 0 plus 3, 3, 4, minus 2, and minus 3. All transpose. So now AB all transpose will be equal to, we are now going to transpose this matrix. Row to column, 3 minus 2. Row to column, 4 and minus 3. So this is AB all transpose. So now let's move to question number 2. It says use cofactor method to find A inverse if A is this much. So now let's see how to solve this question. Number 2A. Given that A inverse is unknown and the matrix A is given by 1 all over 2 sin psi and cos psi and minus 1 all over 2 cos psi, then sin psi. So now we are going to find A inverse of this matrix. So first we are going to find the determinant of this given matrix. This times this, 1 all over 2 sin square psi, then minus this times this, that is minus 1 all over 2 cos square psi. So now A determinant will be equal to 1 by 2 sin square psi, then minus times minus plus 1 by 2 cos square psi. So now A determinant will be equal to, now we can factor 1 all over 2. 1 all over 2 into sin square psi plus cos square psi. So now if we can remember by trig identity, we know that sin square psi plus cos square psi will give us 1. So now we are going to substitute this in here. A determinant will be 1 by 2 into 1. So now A determinant will be equal to 1 by 2 times 1, that is 1 by 2. So now this is our determinant, 1 by 2. So if we can remember, we are asked to find A inverse, where A inverse is equal to 1 all over determinant times adjoint of that A. So we have determinant, this is the determinant, and now we are going to find the adjoint of A. Adjoint of A will be equal to, this is the matrix A given in the question. So now to find the adjoint of A for only 2 by 2 matrix, we change and negate. Only on 2 by 2 matrix. we change and negate. So let's see how to change and negate a 2 by 2 matrix, and that will be its adjoint. So given the matrix as 1 all over 2 sine theta, 1 all over 2 sine theta, sine psi, then cos psi, and minus 1 all over 2 cos psi, then sin psi. So to find the adjoint of this matrix, then what we have to do is we only make this trick. Adjoint A adjoint will be equal to, now we change and negate. These and these are the ones to be changed. They will change position. Sine will come to here. And 1 all over 2 sin psi will be in position of sin psi. And now these and these we negate them. That is minus cos psi and minus into minus 1 all over 2 cos psi. So this is how to change and negate, only done in 2 by 2 matrix. So now we are to find A inverse, which is equal to, we have our determinants, 1 all over 1 all over 2 times the adjoint. This is the adjoint. Then sin psi minus cos psi, then minus times minus, that is 1 all over 2 cos psi, then 1 all over 2 sin psi. So now 1 all over 1 over 2 will be A inverse equal to 2 all over 1, then the adjoint matrix, sin psi 1 minus cos psi, 1 all over 2 cos psi, then 1 all over 2 sin psi. So by multiplying these two and this matrix, then we will obtain our A inverse. A inverse will be equal to 2 times sin psi will be 2 sin psi. 2 times minus cos psi will be minus 2 cos psi. 2 times this will be cos psi, and 2 times this will be sin psi. So this is A inverse. Now let's move to the next question. The next question is question number 2b, which says, let A be this matrix, find number A and B such that A square is equal to I. I is an identity matrix. So number 2b, which says, given A as a matrix of 1, A, 2, and B. And this says in the question, find number A and B such that A square is equal to I. So now A square is equal to I. So we are going to open this matrix as A square will be this matrix 1A 2B times the same matrix 1 2 A and B, and still when we multiply this, a square will be equal to, let's first drop them again, 1a, 2, and b. Then the next matrix, the same matrix, 1, 2a, and b, will be equal to identity matrix. Identity matrix is a matrix which has 1 as it is diagonal term and 0 and 0. 1 as it is diagonal term. Identity matrix is equal to 1, 0, 0, 1. Always 1 as it is diagonal term. So now 1 times 1. A square will be equal to 1 times 1 is 1 plus 2 times a, 2a. Then 1 times 2 is 2 plus 2 times b, 2b. Then a times 1, a, plus b times a, ab. Then a times 2, 2a, plus b times b, which gives b square, which is equal to these identity matrices, 1, 0, 0, and 1. So now we are going to take these equations as component by component. 1 plus 2a will be equal to 1 as equation 1. Then 2 plus 2b will be equal to 0, component by component. 0, equation 2. A plus ab is equal to 0 as equation 3. Then 2a plus b square will be 1 equals to 1 as equation 4 obtained from these matrices. So now we are going to find a from first equation. From the first equation, 1 plus 2a is equal to 1. Then making 2a subject, 2a will be equal to 1 minus 1. 2a will be equal to 0, all over 2, all over 2. A will be equal to 0. So now let's find b from any equation above. From equation number 4, let's carry equation number 4. It says 2a plus b square is equal to 1. 2a plus b square is equal to 1. So we know that a is 0 as we find it. A is equal to 0. We substitute it here. 2 into 0 plus b square will be equal to 1. 0 plus b square will equal to 1. B square will be equal to 1. Then taking the square root of both sides, b square in root will be equal to root of 1. Then square cancel root. B will be equal to root of 1. That is plus or minus 1. So now a and b is a equal to 0 and b equals to plus or minus 1. So that is the values of a and b from the question. Question number 3a says, number 3a, it says, if a and b are symmetric matrices, shows that a plus b is symmetric. So to solve this question, let a be equal to a symmetric matrix. We are to open it ourselves. 1, 2, 2, and 3. Let this be matrix A, and let matrix B to be equal to a matrix of 3, 4, 4, and 5. The symmetric matrices opened ourselves, not given. We are going to open this matrix by ourselves. So now we are going to find A plus B. This A plus B will be 1, 2, 2 and 3 as A, plus the matrix B, 3, 4, 4 and 5. So now A plus B will be equal to a matrix of 1 plus 3, 4, 2 plus 4, 6, 2 plus 4, 6, and 3 plus 5, 8. This is A plus B, and it is also a symmetric matrix. A plus B is a symmetric matrix. So, how do we open a symmetric matrix? Here is a question. How to open a symmetric matrix is always see this matrix 1 and 2. They are in series. 1, then the next 2. Then these two repeat in itself in the second row. It repeats itself, and then 3 follows. Any number can follow. See this 3 and 4, and 4 repeat itself, and any number 5. 1 and 2, and also 2 repeat itself. Then 4 and 6, and 6 repeat itself again. Always the first row should be in series. Then the last number should repeat itself as the first number in the second row. So now let's move to question number 3b. Question number 3b. Question number 3b says use Gauss-Jordan elimination method and matrix inverse method respectively to solve the system. This is the system given, two equations. So we are going to use two different ways to solve this equation. Given the equation as 2x1 plus 3x2 is equal to 4 and x1 plus 2x2 is equal to 2. So we are going to solve these two systems by Gauss-Jordan method and by inverse matrix method. Two different ways. So now solution. Number 1, by inverse matrix method. So now, given this, each variable has its coefficient. This has coefficient of 1. So we are going to put this coefficient in augmented matrix. Here is it. We have 2, we have 1, 3, and 2 as the coefficients. Then we close the matrix. Then our constant variables, x1 and x2. Then we close the matrix. Our equal sign, then our constant values, 4 and 2. So this is the first step. Now let's try to make these variables the subject. x1, x2 to be equal to this matrix but in form of inverse since it crosses the equal sign, and then the constant 4 and 2. So now we change and negate these matrices to remove the inverse. So now here is how to change and negate it. So x1, x2 will be equal to, the two will change their positions, and we negate 3 and 1.